All right, good afternoon, well, good morning, or maybe good evening, ladies and gentlemen. Good morning, everybody. Today, I've been doing the math admission test from University of Oxford, right, for my channel. So today, let's just take a look at how the test looks like. And I got this idea from Toby, like unboxing an exam. So if you want to check out more exam papers, definitely check out Toby's channel, TB's, and I have a video in the link in the description for you guys, right? And truth to be told, I just woke up because I know this is like the time that most people are online. So I just woke up right now. It's only 8 a.m. here. So good morning, everybody. Again, today we are going to take a look at how the math admission test looks like, and this is the one from 2023. So if you do planning to apply to these three colleges, you will have to take this test. All right, good morning, everybody. Hello, everybody. So yeah, I have done several questions from this test already on this channel and also on my blackpenredpen math basic channel. You guys can go check out the videos. Today we are not going to solve the problems. We'll just look at the format of the exam, and what I think is, based on the questions that I've done so far, many of these questions are very well designed. They are not just direct computations. They really make you think. So I like them a lot. But of course, if you have to take this under the exam setting, you'll feel the stress, of course. So it's not going to be too fun. But I do believe if you just look at the questions and try to solve the questions on your own, do it for fun, they are great problems. And again, if you want to check out more unboxing exam videos, definitely check out Toby's videos. I have a link to her videos in the description. Right. So let's just go ahead and get to work. I actually don't know how many people are on live already. All right. So here we go. Math admission test. You can download this. The test is also in the description. You guys can go download that. Okay. I haven't live for a while with you guys, so let's see how it goes. Hello, Li Xiang 老师. Hello. Thank you so much for the super chat. Thank you. For high school students, yes, if you are applying to colleges, of course, from high school, after you graduate from high school, then yes, this is the exam that you take. Okay, so first, we see that you take this exam in October, and we have a total of 2.5 hours to do the test. So this is crucial. You must use a pen, okay? Oh, and I'm not going to solve the questions, but if you guys want to see the answer to any exam questions, let me know because I have the solutions right here, all right? No calculators, and let's see what else are the important things that I should mention. Oh, the exam has 6 questions, but I will say 6 big questions, and we should just do 5 of them. And these are the criteria. So depending on what majors you are applying to, as a mathematics or math stats, math and philosophy, you do 1, 2, 3, 4, 5. If you want to do computer science or math and computer science or computer science and philosophy, 1, 2, 3, 5, 6. And if you're not an Oxford applicant, you should just do 1, 2, 3, 4, 5. So that's that. And now let's take a look at the questions. The first question is actually a collection of several multiple choice questions. So here we go. This is the first one. Okay, I'll zoom in a little bit for you guys. So, first question. In this question, we write alpha as log base 10 of 2, beta as log base 10 of 3, and gamma as log base 10 of 7. Which of the following numbers is close to an integer? Which one is the closest? Alright, so we can try this. If you guys put it in the chat, let me know what you guys get, and I can zoom in this right here for you guys. Which of these numbers is closest to an integer? And remember alpha, beta, and gamma right here. The hint might have a typo. I don't know. Really? If you do 4 times 3 to the 5th power, is it not that? Oh, since it's multiple choice, I will actually just circle the answer for you guys. And I'll show you guys the answer. The answer to number 1, I'll give you guys 10 more seconds. Alright, I'll give you guys like 30 more seconds. I'll let you guys think about it. Just drop your answer in the chat. I can see so many of you guys are answering the questions. Many of you guys are saying D. The answer is not D. I'll tell you guys that. The answer is C. Alright, I'll show you guys the solution real quick. Here's the solution. Again, this is from their official website. So if you work out the numbers, you will see that choice C is 1 plus log base 10 of 9.8. And of course, log base 10 of 9.8 is closest to an integer compared to the other ones. If you have log base 10 of 10, you get 1. So as you can see, the first question is already, making you think a little bit. This is not really just like, hey, direct computation. Because at least you have to check 5 choices and then you have to compute it. Maybe there's a fast way to do it, but on the official solution, it looks like they just computed. So yeah. Now let's take a look at the second one. And this is the one I did on my other channel. It says exactly one of these 5 numbers is a square number and which one? So if you have seen the video that I make on Black Pen, Red Pen Math Basics, then you know the answer already. But if you haven't, you can think about it. Which of this right here is a square number? By square number, it means a perfect square. It means that if you take the square root, you end up with a whole number. All right, so I'll give you guys like 20 more seconds. So I'll just show you guys all the questions and then we'll talk about, well, I will say how to do it a little bit here and there. But again, I'm not going to solve the questions right here. And at the end, I will tell you guys what I think about the exam. I did tell you guys a little bit earlier. I think many of these questions are wonderful. Just make sure that you don't do them on the test if you want to enjoy the question, because when you are taking the exam, you have the stress. But if you just really think through the questions like this one, it's like, yeah, many of the questions are well designed. That's what I mean. C, you use a calculator? Okay. Yes, the answer is C. Would you like to tell me what the answer is if you take the square root of it? What square gives you this? The first question is multiple choice, yes. But by the first question, it actually has like many little ones. C ends with 25, so it has potential. That is the correct idea. That's the correct idea. This one ends with a 9. It also has a potential, but it's not. Yeah, this one cannot be. You cannot end with a 3. You cannot end with 35. And for the last one, you cannot have 3 zeros for a perfect square. Because if you take the square root of this, you can say that's this times square root of 1000. Square root of 1000 is not a perfect square, and square root of this first part is not a whole number either. Yeah, this was a fun one. It really tests you your understanding with square numbers. You can, of course, try to do some special technique of like taking the square roots without a calculator, but that will take too long, of course. 25485? Is that the answer? 25485. 25485. Square gives you this. Yeah? I'm just reading what the chat tells me. So maybe you guys can give me some confirmations, and then we can move on to the next one. Thank you. All right, cool. Checks out. All right, so that's the first two questions. Now moving on to the third multiple choice question, which is C. Right, question C. And then let me zoom out a little bit. Cool. Now we can see the whole question. Each multiple choice question is 4 marks, by the way. So here we have 2 circles in a square like this, and then the square has side length 1, so each side is 1. And we can see that this circle is tangent to that circle. And here it says the area of the larger circle is 10 times the area of the smaller circle. Okay, so this is 10 times the area of that. We are trying to find the sum of the radii of the circles. So we're trying to go from here to here, from here to here. So that's pretty much the radii. So from here to here, and from here to here. The sum of the radii. Anybody want to give it a shot? By the way, you really don't need to use this information here. The area of the larger circle is 10 times the area of the smaller circle. When I first look at the question, like, was wondering, like, why do you need this? It turned out you don't. Do you need it? I really don't think you need it, because it's just the first radius plus the second radius, so it's going from here to here, right? Assuming here is the center and here is the center. I'll give you guys 30 more seconds or so. Yeah, I don't really think you need it. The what's that called? The answer key, right? The solution key also confirms that you don't need it. So that was interesting. Is B correct since it's less than square root of 2? Oh, so are we doing from here to here being square root of 2, and then we just have to make sure it's less than square root of 2? But many of these are less than square root of 2 too, right? For example, this one is also less than square root of 2. This one is bigger than square root of 2, so you can get rid of that. This one's bigger than square root of 2, you can get rid of that. Half of square root of 2 maybe? No? Okay, I'll tell you, the answer is B, 2 minus square root of 2. 2 minus square root of 2. Oh, sorry. Yeah, I think A is also less than square root of 2. Yes, I forgot. As I told you guys, I just woke up not too long ago. It's 8 o'clock in the morning, 8:16 now. So sorry about that. I haven't had my coffee yet. Yeah, I forgot. I don't know why I didn't see the divided by. I was just looking at 1 plus square root of 10. But anyway, though, here is the quick solution if you guys want to take a look. So you just need to go from here to here. This is R1, this is R2. And if you just connect it, you can just kind of follow the solutions right here. 8:16 a.m. perfect time for hard thinking. It's too early for me a little bit, but I know this is the time that most of you guys are online, so yeah. I figure it's fun to do a live. Alright, cool. So now let's move on to D. Alright, this is a fun one as well. How many distinct real solutions X are there to the equation given right here? So if you guys look at this, what degree of this equation is? Let's just talk about what degree this is. We have x squared, and then if you square that, you get the fourth degree, and then if you square that, you get degree 8, and then if you square that again, you get degree 16. So yeah, we can possibly have 16 answers, right? But of course, we are looking for the real answers, and we are looking for the distinct real answers. And you can imagine the moment that you take the square root of both sides, you end up with plus or minus. You also have to worry about if you bring the number to the other side, you still have to make sure it's positive and all that stuff, so you don't get 16 distinct real solutions. So one of these. This one might take a while if you just do it by follow the steps, but it's fun. You have like it's like you have to break it down, and I don't really know if there's a faster way to do it. The solutions way is just like solve it and then keep track of how many solutions there are. So I'll pause for a little bit. You guys can let me know how many solutions there are. All right, I will tell you the answer is C. So far we have like 3 C's already, huh? And here. Oh, I'll show you guys the solution right here. So you just have to like work it out. All right, and then here. So again, just work it out and keep track of how many solutions there are. That's all. I don't know if there's actually a fast way to do it. So if you guys do know, let me know. All right. So that's that. Okay, that's D. And now let's go ahead, look at the next question. Question E. So the first few positive whole numbers that are not powers of 3 are 2, 4, 5, 6, 7, 8, and 10, and so on. So you can see that 1 is not on this because 1 is the same as 3 to the 0th power. And of course, 3 is not right here. It's because 3 is equal to 3 to the 1st power. And 9 is missing because 9 is 3 squared. So we're trying to get rid of all the powers of 3, and that's another way to think about it. We are looking for the sum of all positive whole numbers that are less than 3 to the 10th power and are also not powers of 3. So this is just a difference of 2 series. You have to find the sum from, but you guys can try it. So this one is not so bad either. You did this paper for real this year? Was very fun. Okay, nice. Alright, don't spill the next question. Okay, I will try. I'm sorry, I will try. Yeah, because I have a lot of paper right in front of me. I'll try to be careful. I think this one is not so bad. Many of you guys got it. Alright, 5 more seconds. Alright, cool. Yes, indeed. The answer is D. No, just kidding. A. Alright, so I'll show you guys the solution real quick right here. I'll be careful with not showing you guys the next question. So just subtract these 2 series from 1 to 3 to the 10, and the other one is that one right there. All right. So this one not so bad, right? Now, how about F? Let's see F. Oh, this is a fun one. But if you haven't done things like this, then of course it'll be hard. We are going to find the coefficient of x to the 12th power in the expansion of this expression. And you can see that this is a pretty big one, but there's a little trick to this. So think about it first, of course. Do not try to multiply out the 5th power, the 5th power, the 5th power. Notice they are all 5th powers. Yeah, nice binomials, I agree. Wow, some of you guys got it right away already. So blackpenredpen, just curious, do you know your target audience? Anyone who likes math. I would say anyone who likes math, right? Right, especially for my main channel. Yeah. Okay, ready? I will tell you guys what the answer is. The answer is indeed A. This is a fast way to do it. Well, this is the solution's way. You multiply out the 1 minus 2x and also the 1 plus 2x inside because they are all to the fifth power. So that will be this. And then you can further multiply with 1 plus 4x squared. So it's just this thing to the fifth power. 1 minus 16 to the 16x to the fourth power. And then you raise that to the fifth power. So thankfully, they are all to the fifth power. Imagine if this is to the fourth power and this is to the third power, I think the question will be definitely more difficult. All right, so that's that. And then we have just a few more questions to go for the multiple choice. All right, one more page of multiple choice. Well, one more paper, so page 4 and page 5, so 4 more questions. Okay, now let's see. So here, we have ABC non-zero real numbers, and each of the following quadratic equations has a repeated real root, but they are not necessarily the same value. So we have the quadratic equation ax squared plus bx plus c equals 0, and the other one bx squared plus cx plus a equals 0. We would like to know how many distinct real roots the equation cx squared plus ax plus b equal to 0 have. Yeah, definitely need to use, like the b squared minus 4ac, the discriminant. All right, so this one right here, it's pretty fun too. Use the discriminant. It's not so bad. The answer might surprise you. Right, so use the discriminant for this quadratic equation. So you do b squared minus 4ac, right? It has a repeated root, so you have to think about what that means. And then right here, if you also do the discriminant, c squared minus 4ba, right? It also has a repeated real root, so you have to think about how you can use the discriminant. And you check the discriminant. Here will be a squared minus 4cb. All right, I will tell you, you really don't have any real roots for this equation. It's pretty fun. I like how they do it. It's like you have A, B, C, and then B, C, A, and last is C, A, B. So it's just a permutation of the A, B, C, the coefficients of the quadratic equation. Yep. You guys want to see the solutions? I'll cover this. You guys won't see it. It looks like this. Right, b squared minus 4ac, in order to have a repeated root, it has to be equal to 0, so b squared equals 4ac, likewise for this. And then just kind of do some algebra work, and you will see the discriminant of the third quadratic is negative 63a squared, and this is always negative, because a is not 0. So it has no real roots. Okay, cool. They do say A, B, C are non-zero right here, so we can have they equal to 0. All right, I also did this one in a video on my blackpenredpen math basics channel. Which of these triangles has the biggest area? So triangles with sides 10, 10, 1, 10, 10, 5, 10, 10, 10, 10, 10, 15, 10, 10, 19. So at first you might think 10, 10, 10, right? Because equilateral triangle. But the thing is that that's only when we have fixed perimeter. But we are not compare triangles with the same perimeter. So the perimeter of D is bigger than C. So we cannot just say the equilateral triangle has the biggest area. It's true that among all the triangles with the same perimeter, the equilateral triangle will be the biggest triangle. But here, no, we cannot use that. I'll give you guys 20 seconds. And I don't think you want to go for E. If you think about it, 10, 10, 19. Though I'll try to draw it. 10, 10, 19. Right, it's going to be pretty flat. It's like 10, 10, 19, somewhat like this. Because this is almost a 10, 10, 20. If it's 10, 10, 20, you don't have a triangle. It's just like a straight line. So it's a little, it's like really, really flat like that. So I don't think it's E. You can try to use the Heron's formula. That would be a little bit overkill in my opinion. Alright, here you guys, the answer is D. Because notice they are all 10, 10, right? They all have 10, 10, so you just have to compare the third side. So imagine if we have two sides already 10 and 10. And then how can we get the third side so that the triangle becomes the biggest? Well, if you call this alpha, let's say theta, then you can see that the area of this triangle is just 1/2 this times that, which is 10 times 10 times sine of, did I say alpha or theta? I forgot, but like anyway, theta. You want to maximize this. And in order for this to be maximized, this has to be 1, which is saying that theta should be 90 degrees. So think about which one will give you closest to have a 90-degree angle. If this is 90 degree, you actually have a 45, 45, 90 special triangle, right? So the hypotenuse will be square root of 2 times 10. And square root of 2 is about 1.414. All right? So can you guess that? Okay, cool. All right, how are we doing so far? So far, so good. So far, so fun. All right, 2 more multiple choice questions. So for this one, the polynomial p of x has degree 3, and it says p of 0 is equal to 0, p of 1 is equal to 1, p of 2 is equal to 2. The polynomial has a repeated root at x equals m. M is greater than 0. We need to know the value of m. So for this one, you really do have to know the language of polynomials, like what do we mean by repeated root, and then the structure of the polynomial that has a repeated root. So what kind of form you can use, you know? So far notice we haven't done any calculus related questions yet. But some of you guys might saw it earlier. Yep, J is going to be a calculus question. But let's focus on I. Aha, yes, target Vn, you are right. Ax times parentheses x minus m and then the second power. So that is the form. Yeah, so we have to work with that form. And yes, many of you guys are putting down similar forms in the chat as well. All right, I will tell you the answer in the interest of time. The answer is all right, yes, E, 3/2, 3/2, right? Yes, we are going back to the OG camera format. Yeah, black pen, red pen, right? This is how I started with my YouTube channel. Today, black pen is missing because the questions are in black already. So I figure I just need to hold a red pen so I can use this as a pointer. Now, J. If I remember correctly, this is the only calculus question on the test. So to my surprise, it's like, we have a calculus question and we don't have any other calculus questions later. But anyway, let's take a look right here. We pretty much have to integrate from 0 to 2 of this function, which is 3/4 raised to the power of the floor function of log base 2 of x. So this one is going to be tough if you're not familiar with the floor function. It looks intimidating, but if you think about it, whenever you have the floor function, it's like a staircase. So that's a little hint. I'll give you guys 20 seconds to put whatever you want to put in the chat. I'm reading it. Yeah, we'll get a bunch of rectangles pretty much. Ready? I'll tell you. The answer is C. I'll show you the picture real quick. You'll get a bunch of rectangles like this. And the fun part is that right here, we have infinitely many rectangles and they each have the width and 4/3 of the height of the previous one. So reading it from right to left. So this one and then this right here is half, but it's taller, 4/3. And then just think about how do you find the area of these rectangles and then add them up. And you get a geometry series. And we have the first term being 1 and then the common ratio 2/3. All right. So as we can see, the first question, it has like A, B, C, D, E, F, G, H, I, J, right? These parts, multiple choice, and that's just consider one question, right? We have to do a total of 5. So the first one was like a first big one. Now, for the second question, this is for all applicants, regardless your intending major, right? Because there's a difference between if you apply as a math major versus math and computer science. But anyway, though, this one right here, we have a not really a polynomial, it's just Pn of x. The function defined it to be x to the n plus x to the negative n. First, we're going to sketch P1, so not so bad. It's just x plus 1 over x. And then label the turning points. Not so bad. Next, we are going to show that P2 is equal to P1 squared minus 2. So the little recursive formula right here. So again, not so bad. Just do some algebra work, she'll do it. And then part 3, kind of similar. We just have to do P3 in terms of P1. Not so bad. Yep. And after that, this question is 5 marks. Remember, one multiple choice question is 4 marks, and this right here, you will see some higher marks question. So number 4, 5 marks, we have to solve this equation. So even though this is a quadratic equation, but of course they are related. So you can think about how to do it. But notice 1, 1, negative 10, 1, 1. So this is kind of cool. And then the last question is also to solve this equation. It's a 7th degree polynomial equation, but in fact, even though you didn't have the previous parts, you should recognize how to solve this kind of equations. Notice the coefficients are 1, 2, negative 5, negative 7, 7, 5, negative 2, and 1. If you look at the absolute value of the coefficients, you can see that 1, 2, 5, 7, and then 7, 5, 2, 1. They're just off by negative signs, right? This is positive, this is negative, and so on. So you can think about how to do it. Maybe I'll make a video on my BPRP Math Basics channel to show you guys how to solve this kind of equations. All right, so this is a fun one. Just solving equation for that. I'll leave that to you guys if you want to try them out later. All right, number 3. And again, this is like a big question. Let me see. All right, so, okay, that's just a general direction. Part 1, without differentiating, write down the maximum value of cosine of 2x plus 30 degrees. Right. This right here, you can really just tell me the answer right now too. You really don't need to use calculus derivative. Yeah, the maximum value of cosine of anything, just 1. Yeah. So it's only 1 mark. All right, part 2. Again, without differentiating, we're going to find the maximum value of this function. So notice right here we have cosine, cosine, and luckily here, the inputs are the same. So this right here, again, you don't really need to do anything fancy. And you can tell me what the answer is, like right away too, almost right away. It's kind of like a quadratic. It's not sine squared though, because you have to distribute this times 1 as well. So you can treat this as, like t times 1 minus t squared, because this and that are the same. And then you find the max for that. The max is 1 over 4, yes. Yeah, turn that into a quadratic, right? And then part 3. Again, we are going to find the maximum value, and this time we have the 5th degree. And again, it's nice because they are both to the 5th power. So not so bad. Not so bad. Once we know this, you can put down the answer for this one almost right away too. And then part 4, we are going to find the maximum value again, but this time is this expression. So for this one, we have to think about this a little bit. Yeah, for this one, it's just you take the previous answer, you raise that to the 5th degree. Yeah, so for this one, the answer was 1 over 4. For this one, you just do 1 over 4 and then the 5th power that too. Done. And the first question right here is 1. Alright, for this one, we will have to think about this a little bit. But you can see the powers, they are different. But this right here is actually cosine square, and we have a 1 right here. So maybe you can do something about it, right? So this will give you sine squared. And then because we have sine squared inside, to the 4th power, so that will give you the 8th power as well. So perhaps I'll give you guys a little note right here. This is the same as sine squared, and then we have 3x minus 60 degrees, like this. And here you might notice that the input is different, but you can change that. Just have to remember the connection between sine and cosine. I'll write that down for you guys. You can say that cosine of an angle equals sine of, because they're using degrees, we'll put 90 degrees minus the angle. Or you can also say that sine of the angle equals cosine of 90 degrees minus the angle. But of course, we'll use the first one, because right here we have sine already. This right here should also be turning to sine, so that it's easier for us to work with. And the answer for this one is 4 to the 8th power. Right? So far, I think the questions are pretty nice. If you have, study and prepare for the exams, not so bad. I haven't seen anything like super insanely hard or something. All right, number 4. So math stats, and if you're not applying to Oxford, right, you do this. All right, so point A is on the parabola y equals 1/2 x squared, and we have this point a comma 1/2 a squared. A is greater than 0, and the line L is normal to the parabola at A, and then point B lies on L such that the distance AB is fixed, positive number D, with B above and to the left of A. So for this one, you definitely should draw a picture along the way to visualize what's going on. Part 1, 6 marks. So yeah, you can imagine this is the hardest part. We will find the coordinate of B in terms of A and D. All right, so yeah, that will take some time, I will say. And then part 2, we are going to show that in order for B to lie on the parabola, we must have this condition. Of course, I didn't work it out, so I wouldn't be able to do anything. So, okay. And then part 3, if we let t equal to a squared, and then we just work with this inequality, we will should get d to the 2/3 equals f of t for some function, and we should determine what the function is. So it looks like just a substitution question from here. And then the last part is we will find the maximum value of this function. And then hence we will show that star holds for some real value a if and only if d is greater than or equal to some value, which you should identify. All right, so I think this right here, it will take a while to think through it and then to understand the question and all that. And I'll just move on to the next one. Alright, perhaps I'll show you guys the solution for this one real quick. It's like this. Especially for the people who are watching the video, you guys can just pause the video so you can read through the solution. Or you can also download the solution from the official website. The link to the solution is also in the description. This is the one from 2023. Alright, let's just go over 2 more questions because there are just 2 more left. But the last question, I have no idea because I don't do computer science. So I cannot really go over that one. So last question right here. So I have to look at a lot of the Oxford math exams. It seems that they really like to use a Fibonacci sequence. And one thing I noticed is that there's only one question that you have to use calculus, which is the last question of the multiple choice question that you have to do an integration. Other than that, all this right here are just algebra. So I'm not sure why that is the case. And let's just focus on number 5. We have the standard Fibonacci sequence. F1 is 1, F2 is 1. And then just have to write down F3, F4, and F5. So not so bad. And then using star repeatedly in terms of n, how many additions do you have to calculate to get Fn? Right, so you just have to count how many additions is happening. Now, for example, F3, right, you have to add F1 and F2, so you just need 1 addition. F4, you just need 2 additions, right? So not so bad. All right, now this right here, it's a little bit harder now. Now we consider the sequence of zeros and ones of length n that do not have 2 consecutive ones. For example, if we have n is equal to 5, then this is an okay sequence, 0, 1, 0, 0, 1, or 1, 0, 1, 0, 1, because you don't have 1 ones, right? Or 1, 1, 1, that's not good. And this right here is bad because you have the 1 and 1 right next to each other. So that violates with this right here. And then we're going to let Sm denote the number of valid sequence of length n. And for this one, you just have to count. So this is a little bit counting question. We have to find S1 and S2. Right, I'll leave that to you guys. And then for the next question, for n is greater than or equal to 3, by considering the first element of the sequence of zeros and ones, we will show that Sn satisfy the same equation star. So Fibonacci sequence relation, right? And then we will conclude that Sn equals Fn plus 2 for On. So that's kind of fun. Again, it's a beautiful question from the Fibonacci sequence. I have done a very nice Fibonacci sequence video from the Oxford Math Admission Test. I will link that to you guys in the description later on too, because I thought that was really nice. So kind of computer science related too, in my opinion. All right, and then next one. By considering the valid sequence of length 2n minus 3, and we will focus on the n minus 1's position. All right, this is, we have to show this relation. And one thing I'm not so sure is like, whenever it asks us to show certain things, that how much detail do we have to provide? Because sometimes maybe this is just quite clear if you just look at the pattern. So yeah. And then the next one, if n is greater than or equal to 2, again you have to show this condition. So yeah, I'm not sure that how they will want you to show it to prove it. All right. And then the last one, if k is greater than or equal to 3, use this equation and that equation, and then we have to count how many arithmetic operation we have to do to calculate f sub 2 to the k. Alright, so yeah, for this one, I will have to think about like how to do. Maybe I have to look at the solutions to understand how they expect you to do it. So yeah, I'm not entirely sure on how to do it. And the last question, question number 6, it's for computer science majors only. And it's about a tree like this. So I will just show you guys the questions. Okay. So I'm not even going to go over this because I don't know about what the question is asking, because I don't know this computer science question here. All right. So let's just kind of summarize this real quick. So what do you guys think about the test? What do you guys think about the test? I think a lot of you guys were really engaged when we're doing the multiple choice questions. All right, so hard for you, but fun. Okay, yes, I do think a lot of the questions are very nicely created. It's not just that, hey, this is the quadratic equation, you have to solve it. Those will be more like, cut and dry. But this right here, you really have to think about all the things you have learned. Like for example, this one. So what have you learned about the quadratic formula and how do you use and apply it? You wouldn't have passed probably. Well, if I am the one who took the test right on the spot, and if you time me 2.5 hours, I don't know how I will do it either. But if you don't have the exam pressure and just do the question, I think many of the questions are very fun. All right, you should make a video going through step 2 or 3. Okay, I will think about it because I printed this out already, and then I figure it'll be fun to do a live going over the test with you guys. So it's like a little unboxing the exam, especially if you guys haven't seen the math admission test from Oxford yet. They have a lot of great stuff, of course. And again, to my surprise, it's just that we only have one calculus question. But maybe it's just because of this year, right? This is from 2023. You can also look at the other exams from the previous years. All right. So this is the test for graduating high school students when they apply to college, or maybe like the senior year of high school, right? Because you take this exam in October. I think it's a pretty fair test, right? First off, I think this is a pretty fair test. You just have to know your stuff, right? I don't think there are any like super low computation, but you just have to know what's going on and use the ideas of what you have learned, right? The properties of quadratic formulas, the discriminant, sometimes maybe the Fietas formula, and of course it seems that they love the Fibonacci sequence because I've seen many questions on the Fibonacci sequence already. All right, today, this is our first time unboxing the math admission test. Maybe next time we can do something else. And if you guys want to check out another unboxing video, you should definitely check out videos by TBs. I have the link to our video in the description. You guys can definitely check that out. All right. Until then, I'll see you guys next time. Bye.